Okay, let's get into all of these reactions. So we're going to go through 4 different types of nuclear decay reactions. And I want you to be able to recreate these reactions. And I'll show you how, an easy way that we could balance these types of reactions and remember how to get them right. Okay, so first one we'll talk about is alpha. So alpha particle decay. So this is a nuclear reaction in which an unstable nuclide spontaneously emits an alpha particle. So we note spontaneously, right? So delta G for this process is negative. It just happens, okay? And so this is mostly what I'll say, heavy nuclides. And by the heavy nuclides, I'm talking about things like uranium or thorium, right? The massive nuclides. Things that have a huge abundance of neutrons. And you notice with uranium-238, it's got 92 protons and, whatever 238 minus 92, that many neutrons. So way more neutrons than it does protons. So it is unstable, okay? And so in all of these reactions, it spits out an alpha particle. And we note here, as a result, the mass number has to change. However, the mass numbers also have to add up and balance, okay? So for example, if I'm starting with uranium-238, okay, then when it spits out an alpha particle, it's losing a mass number of 4. So that has to become 234, right? 238 minus 4 is 234. But also it has to lose 2 protons. So that U92 becomes 90. And we know that this produces a thorium nuclide because if I look at my table right here, I always get lost way down at the bottom of the table, wherever it is. Where are you, heavy things? Let's see. I'm probably like hovering right over it. Uranium. Oh my God. I never look at the lanthanides and actinides. Okay. So there's uranium. It's number 92. Sorry that the font is small. I think that I could zoom in on that table right here. Yes. Okay. Lovely. So, yes. So we can see right here, it's U92. And because it lost 2 protons, it becomes element number 90. So we recognize that has to be thorium. Okay, so here's another example. As it were, thorium-230 also undergoes alpha particle decay. I'm not going to make you memorize which one does what, but you should have a general idea that this is exhibited in the heavy nuclei. Okay, so in thorium, it's definitely a heavy nuclei and has way more neutrons than protons. So you can see its mass number is going to change by 4, right? So 230 minus 4 gives me 226. Also, its atomic number is going to change by 2. So it's going to go 90 minus 2 gives me 88. And if I look here, number 88, and of course, it's all the way over on the other side. There, wait, number 88, there it is, radon, okay? So that's our alpha particle decay. Next video will be on beta.